Most AI comparisons read like marketing material. On one side, you have OpenAI maximalists dismissing Web3 AI as a slow, useless gimmick. On the other, crypto advocates pretending decentralized networks have already crushed GPT-4. Both are wrong. I use both of these ecosystems daily. I have no corporate sponsors and no ideology in this fight, just hands-on testing to see what actually holds up in practice. If you blindly lock yourself into just one of these camps, you're set in a trap for yourself. You will either drastically overpay for simple tasks, or you'll watch your system completely fail when you need it to handle complex reasoning. Succeeding here requires treating AI as a spectrum of resource allocation. Every decision involves weighing a convenience premium against a sovereignty discount to find the most efficient fit for your specific workflow. This chart maps the trade-off. X-axis is infrastructure control, Y-axis is capability. Centralized AI dominate top left, delivering superior reasoning but surrendering control. Decentralized AI sits bottom right, granting maximum privacy but sacrificing intelligence. Today, open models push the decentralized cluster upward, shrinking the gap. Your goal shouldn't be to pick a single winner. Your goal is to build a hybrid strategy, dropping specific workloads right into the most efficient quadrant for the task. Let's look at exactly what you're buying with centralized AI, like Claude, Gemini, or OpenAI. Today, they own the absolute frontier. If you need complex logic or massive, long context document analysis, they beat any open-weight alternative available. You are also buying a highly polished developer experience. You sign up, grab an API key, and you go from zero to a working prototype in an afternoon, backed by strict uptime guarantees and dedicated engineering teams. They maintain an undeniable lead on multimodal tasks. For native vision, audio processing, and tool use, the centralized giants are years ahead. But this comes with a steep convenience premium. To access this intelligence, your prompts, your proprietary data, and your outputs have to live on corporate servers, subject to data harvesting. You also introduce major operational risks. A safety team might suddenly update a policy and refuse your legitimate requests. Or an infrastructure outage at headquarters can take down every single application relying on their API. Relying entirely on centralized APIs is like renting a high-performance race car. The speed is exhilarating, but you don't own the vehicle, and the dealership holds a remote kill switch they can pull at any time. This brings us to decentralized AI compute networks, platforms like Akash, Morpheus, and BitTensor. Their primary competitive weapon in this market is massive, unavoidable cost reduction. This bar chart compares AWS equivalent GPU compute pricing against decentralized network listings. For the exact same hardware, decentralized compute consistently undercuts traditional cloud providers by 50 to 80%. You also gain complete censorship resistance. If you are running medical research, legal analysis, or cybersecurity probing, you need raw inference. You cannot afford to have a corporate safety guardrail randomly blocking your workflow. These networks are inherently permissionless. There are no KYC checks, no geographic blockades, and no corporate waitlists. You connect and use the compute. Because these are decentralized protocols, users can actually own the underlying infrastructure. Running nodes earns you token yield and governance rights, turning you into a network stakeholder. The critical trade-off here is physical latency. Routing your requests through multiple decentralized node selections inherently adds physical network overhead to every generation. Decentralized AI trades instantaneous real-time speed for operational freedom. You get absolute network resilience and unbeatable economics for your heaviest, non-latency sensitive workloads. What makes this all viable today is how capable open weight models have actually gotten. Releases like Llama 4 and Qwen 3.5 are now highly competitive with closed models for practical daily tasks. They achieve this through extreme architectural efficiency. By using a mixture of experts design, massive models with hundreds of billions of parameters only activate a tiny fraction of them per prompt, saving enormous amounts of compute. This efficiency made local processing a reality, driven largely by Apple Silicon and unified memory architectures that finally allowed normal machines to process heavy logic. Today, you can run a quantized, compressed large language model right on a Mac Studio. It delivers 80 to 90% of full precision reasoning quality, at a fraction of the cost of cloud processing. Running locally gives you the ultimate privacy guarantee. Your proprietary code and sensitive data legally and physically never leave your machine. The main barrier to entry is simply buying the hardware. Achieving this requires a significant upfront capital expenditure on a high-end machine. But once you make that investment, your ongoing costs drop to zero. The combination of open weights and local hardware has commoditized the good enough tier of AI, permanently shrinking the moat of the centralized giants. The modern professional cannot afford single-platform loyalty anymore. You need to dynamically route your tasks based on what you actually care about for a specific job: latency, cost, or privacy. This decision tree is the framework. For complex reasoning with minimal latency, route to centralized APIs. For batch processing or uncensored outputs, follow the path to decentralized networks. And for confidential data or offline capability, route to local hardware. This is exactly how I structure my daily reality: centralized models for the hardest problems, local hardware for private first drafts, and decentralized networks for earning yield. Open models and decentralized compute are improving at a velocity that makes their eventual collision with the centralized frontier inevitable. Technological sovereignty rests on your ability to choose. It means maintaining the structural option to stand independent when necessary, while only accepting the trade-offs of convenience when they serve your specific goals.